Okay, am I on TV? Okay, how long do I have? How many minutes do I have?
30 minutes.
30?
Yeah.
Okay. So, alright, nice to be here. Today I'm sharing a little side project that I have, which is built with Electron. I call it Space Radar. Yeah, this is just a different title, like the things that I've learned building this app. And although it's called Space Radar, it has nothing to do with like the outer space or the radar that users radio with. So because I think there are already a lot of these applications out there, and I think I just started, this radar is like one of the names which was not being used. But when I actually Googled that, right, there is actually something really called space radar, which is like satellite in space, like, I don't know, shooting radio waves. But anyway, yeah, because this is Electron, and I thought it's space and radar. Yeah, and I think Simon last year gave actually a space simulation, so this is a different kind of space. So I'm sure, I think 2 meetups ago, I think Chian actually gave a talk on Electron. It was titled like Getting Excited on Electron. Today it might be getting a little disappointed with Electron. Yeah, I wasn't around, but I actually caught his video online. So thanks, Engineers.SG. So how I started Electron was I was actually at the Taiwan.js the JavaScript conference, and there was a workshop on Electron, and I thought, okay, let me just try it out. This is a really cool. I think it's a very comprehensive presentation. If anybody who wants to learn more about Electron, or building cross-platform desktop applications with Electron, you can click on the link. So that was what I did. Like, I was sitting there and okay, I heard about Electron, so let me start doing that. And so there it turns out to be pretty simple. First, you need to have a main.js, and then you require the stuff, and you see that you add like event listeners on when windows are closed, on when the app is ready, and you kind of open a new browser window. So the browser window is like basically a Chrome browser, and that is actually basically your application that your Electron application. The next thing is index.html. So you're basically saying, open the browser window and load up index.html. If you see over here, there's a file directory name, index.html. So you're basically just, well, I got a typo there, but okay. It still works. Okay, so this is HTML. It works. So I wrote, okay, a simple hello world app, and this HTML web technology. And how do you run Electron? So one way is that if you have npm installed, you have node installed, you can just npm install -g for global, and then you can that will install like Electron pre-built into your system, and you just have to run Electron which basically means run the main.js in your directory. And I said like you could create an Electron app in less than 4 steps. So by the 3rd step, you are already running an Electron app. So if let's say, do you want to let me do a demo? Okay, let me just. Wow. This is really high resolution. Okay, so yeah, this was my project, and actually I did commit the first. Oops. Sorry. a little nervous and you can just run Electron. Ta-da! Hello world! Alright. Okay, so let's go back. And this is if you think, wow, it's so awesome. I'm a JavaScript developer and I can actually create an app. So this packaging where you this npm module which helps you with packaging. And if you run this command, it basically generates a map application that's the platform Darwin. And you can actually target it for Windows and just put platform equal to Win32. And it will generate like the binaries which you can zip it up, send it to a friend to run. So yeah, that's for Hello World in less than 4 steps. So so I think Electron is really fun. I did actually try Node WebKit in the past, and basically using HTML and JavaScript, you could actually create you could have an app which you can package and for somebody to download and run it. And as I continue to play a little, you feel comfortable because you can actually use whatever the way you write Node code, or the way that you develop for the front end, and you use Chrome to view a web page. So basically, as a JavaScript developer, you now have an avenue where you can actually write native apps. So actually now come to why I actually wrote this app is that, like for example, I wanted to upgrade to App Store update, and they say, oh, you do not have enough space. And so this is what I usually get, like because this is a MacBook Air, and it's running like SSD, and it's really easy to fill out your space really fast. So of course, the thing to do is like figure out what's taking up all my disk space. And it turns out that there's one way you can do that is to run the du command, and it's kind of an interesting question. Okay, du is like any decent developer who knows Linux command would know, but it turns out, wow, there's actually so many answers, and different permutations where you can du and you can grab it, you can sort it, just it's quite entertaining to read that track. But for me, I think it's like I want to know where my space go to, but every time I want to run a du command, what was that switch, and then I will have to go and Google that, and then I'll go back to this Stack Exchange thread. So basically, this app is like scratching my itch, to actually have an app to visualize my disk space. And so when I was playing around with Electron, I said, oh, well, there's a really cool visualization library called D3. And if you go to its gallery, you can see, wow, there's a lot of beautiful kind of charts. And one of them, if you see over here, is called the sunburst visualization. And over here you can see the tree-man visualization. And it turns out that these visualizations were actually useful for this for this space visualization. Although D3 being a JavaScript library has been used to create lots of interactive visualization on the web. So how do you use D3? Of course, you can download it. In this case, I npm install it. And one way to get started is that Mike Woodstock, who's like one of the creator of D3, actually has this webpage called Blocks, where he actually writes snippets on and examples where it becomes a way that you can actually learn through the examples. So basically, I just went to his example of like sunburst visualization, and you'll be able to see the code. And yeah, as I mentioned, that sunburst was actually like this research project, and it looks like from really old computers. But anyway, this is like a summary of that. They asked users to use like Sunburst and tree maps visualization, and in general, the participants preferred the Sunburst tool, which is like which looks like flares coming out from the sun. Did I miss something? Okay, so imagine that I actually combine them together. And so actually D3 is pretty awesome. I think it can be another talk, like how you can use that for transitions, how it handles data binding in a really cool way. So the other library which I always use is Tree.js, but this time it's D3. So both of them are really cool. Like, the next thing is that so I thought, okay, well, I have a graph component. Now I just need to get the data like from my disk, like how much space is what are my files taking, how much space, and I could actually write. I was then I was taking a break in Taiwan, and I was probably on the train, and I think I did not have internet, and I just kind of wrote like just 30 lines of code, and you could actually traverse your file system and calculate the total file size of this. So this is my first take on like finding out where this space. So basically it says explore a directory, and you use lstat, which is you find what is the data. The file system information on that file, which could be a file or it could be a directory. So you have an if a stat is file or it's directory, and if it's a directory, you do a read directory sync, and you can traverse that, and that becomes a recursion. So in this case, like I just use sync because it's convenient, right? And yeah, and there you go. I could start to that is like this visualization app that in less than not a lot of code, and you could actually write this visualization app. Yeah. So of course, years ago, I remember in Windows, like Windows 95, there's this freeware app called Scanner 2. So I think that was when I had the inception that actually, wow, this is actually a really cool visualization tool. Yeah. So I think just using this, it's like you could create an app. So of course, as it turns out that if you want it to be an app that you can put in the App Store, you need to do more work. You need to think of the interfaces, and this is like just throwing the tree map in. So it's like it's not so it's not a happy ending yet. So it turns out that this scanning can be tough. The next challenge that I met is how do I scan my entire hard disk? When I tried this prototype, like wrote the code in a really short time. I scanned it with a couple of directories and it worked well. But the question is, how do I want to scan my entire drive, right? So I tried different approaches. So first, like just now you see the synchronous method, and then I looked, when I got back the internet, I said, oh, there must be somebody who writes some node module out there, and sure, there's a node DU, right? And it turns out that there's somebody familiar that I know who has contributed to that project, all right? And so, but that it's great to actually use node modules, but in this case, it does not fit all my needs because this returns me like the total results and not the breakdown of the individual subdirectories. So and then I tried to use Async Queue. So to give a bit of okay, so let me backtrack a bit to say that the why are we not using synchronous method? So I mean, as if you're a node user, you know that synchronous will basically block JavaScript, the JavaScript thread until after the operation is completed. So when you run it in Electron, right? that principle applies. Basically, when you're running a synchronous job, basically your UI will be frozen. So that is why you want to use like synchronous calls. And so so I thought, actually Node.du was using this library called Async, right? So I thought, okay, I'll give Async a try. And one of the things that I did was to wrap my the recursive file scanning into the async queue. So this is basically how you would use the async. The queue will call back a function when all the tasks are completed, and you basically wrap your the previous explore function, and you push like the job that you want to be done next, and so basically that can be done asynchronously. And one of the things that Async Queue does is that you can have a limit on the number of parallel jobs. So I set it to 10 to start, and then I set it to like different numbers just to explore. And it turns out that it solved the problem of not locking my UI, but there was a problem. Like it felt like it was taking a really long time to scan like my disk. Right. When I scanned my drive, it took 40 minutes. I decided, okay, let me just let it run and see like how long it takes. Right. And I decided after that, let me just throw away this library. I will just use asynchronous call. And so that was what I did. I changed the code to basically use without any modules, just read directory, else stat, and it gave me like a speed up of like 10x. So instead of 40 minutes, it's 4 minutes. And I compared that with the speed of DU, and DU was giving me around 4 minutes for my entire hard disk. So it means that actually, wow, actually Node is actually really fast, right? And only after that, then I thought about it. It could just be, the async queue implementation. And I think some people would recommend Bluebird if you want to, you want it to be performant. But I've not dived into that. So yes, it turns out that this is a common problem. There's a thread on Electron, and I think at the start where people were complaining, even the Atom editor seems to be locked up when you are scanning files, and like VS Code actually does a better job. So some commenters will say, oh, actually VS Code actually spin off another process and run that in that process, and so I gone around my journey to like figure out how I can best do that. And so this is surprisingly that this isn't really well documented. I think this chart was actually done by someone else. But you see the orange, it's called the browser process. Strangely, it's not the browser window. It basically means the Electron, the first place where you launch Electron, that's the browser process. And that's a parent. And that basically runs main.js. And when you create a new browser window, you call that the renderer process. Right? And the render process basically loads HTML, loads JavaScript. And those JavaScript has no integration. So this is basically how Electron works. And this is and actually Electron, when you start to do beyond that hello world, right? You may need to communicate. You can actually create new browser windows, and you can actually communicate among them. But how it gets communicated is that the render process and the browser process can do IPC calls. So you could actually send message to the render process, and the render process can send messages back to the browser process. But when you want to send a renderer process to another renderer process, then you might have to do some code to hop around. But and so if you look at the API, there's this thing called remote. So remote basically encapsulates some of those IPC calls, so that you're basically saying that instead of you sending a message down and handling the code in main.js, you can actually, from your browser, process a remote, which is basically main.js, and you can receive a message and pass it to another render process. I hope it's not confusing, but you could actually read up on this. So what I did was basically that, similar to that, I basically say, okay, let me try running the DU operation, which is scanning all of these, the I/O intensive operation by spinning off a different process, and that would run, and it could be like 4 minutes long, it could be 10 minutes long. And so one of the things that I use IPC is that while it's scanning, I'm going to send like my progress updates, through IPC calls back to the first renderer process. That so your UI can actually say, oh, it's still scanning. You could actually preview stuff without waiting for the entire job to complete. So the first one easy way that I did not have to do that is just to say, okay, just please wait, But I just kind of went down this path of, thinking that, well, while it's doing something, let me preview something in the main render process. And so what I did, so what happens is that I generate a JSON which basically represents your file structure, your directory structure. So basically file size, and with the directory, then it'll be directory with children, and so on. And the next roadblock that I found is that, oops, that JSON is getting larger and larger. And soon, when I'm trying to pass the object through IPC, it's basically saying your message is too large, like don't do that, that doesn't work. So I tried like many different approaches. So backview is basically a way to have a different Electron process, but that's like running in an iframe in your current browser. A fork node process means that you can actually fork an Electron process, but treat it as like a node process. And the way which I ended up doing was to fork it and make the Electron window invisible. And how I transfer the data, when I discovered that I could use local storage, since they are both Chromium, and local storage has this property where when you update a key, all other browsers on the same domain would be able to get a change event. And I used that hack in some other places too, and I reused that, and it turns out to work pretty well. But local storage also have a limitation, which size limitation. This was a little IPC using UDS project that I tried out. It turns out you can send like 100,000 messages a second. But so I tried all of them, and a lot more stuff. And I think the final decision was that I would use local storage when something is less than 10 megabytes, and when it's above 10 megabytes, when it hits the storage limit. Since the nice thing about Electron is that it has like node permissions, and you can write a message to the file system, and then I will use a local storage to send a message over asking the other render process to read it. And it turns out that it's really efficient. Right, I did a lot of like tests with that, and I could like scan 170 gigs of my space, and and so this was like my first one of my first release. So basically you can see that the things is scanning. I think there was a bit of latency. I don't remember why. But when you're JSON passing a big JSON file, it's but more or less it was very reactive and fast, like that 10x, and almost fast or faster than DU. All right. So some other things that I learned that JavaScript objects are expensive. So one of the things that you have to take note is that Electron process has to be kept under 1.5 gig of memory, otherwise it will crash. So I think that's default in. I'm not sure what defaults are there, but yeah, I think if Node that could be Node default, right? And objects themselves has a memory cost. So when I'm serializing and passing over my whole the whole representation of my disk, it was 150 megs in JSON. But when users have to JSON parse that in any node process, and you will find that, well, it's like 400 meg in your heap memory, or like almost like 800 meg in your RSS. So when I'm doing that, I have to make sure that I have to be careful. Like I have my charts is displaying data, I have to deallocate them, make sure that it gets garbage collection, and then render the new graph. Right? That 120 meg of JSON has actually 2 million objects. So actually, there's actually so many objects in your file system, and just like, and if you try inserting 2 million keys in a JavaScript object, right, you'll start to face a challenge. And I mean, if you're doing Node at scale, right, then you face this problem. Like one of the library which my colleague has written is Judy FFI. Judy what do you call structures, data structures is an efficient way of like storing max of data, and 2 million keys. I think we tested that, and it was like it doesn't use any much heap memory, and it's not within V8 heap, but it's actually using nodes heap, which is almost like the way you do things in C, right? So other approaches which I tried was like using flat buffers, which is this actually serialization. One of the hotter topics like flat buffers, Captain Proto, simple binary encoding. These are serialization methods which they claim to be really fast because of zero copy. Like in C, you can actually read from the memory directly without having to deserialize that. So I thought, could I try that for JavaScript? And it turns out that Captain Proto, there's a couple of JavaScript implementations of that, but it didn't turn out to be really usable for me, or it was a bit complicated. And it turns out flat buffers has a JavaScript implementation which was which was much, although there's no documentation, but you should try that. It's really cool. So when I use flat buffers, it takes up like just 100 meg of heap memory, right? And I think I'll get to that in the next slide. I say why I say JavaScript objects are fast, because when I use flat buffers, although it's 0 seconds deserialization, but for me to actually read to read that data structure, right, there's certain cost involved that takes me 5 seconds. While the JavaScript object, maybe it takes 1 second to JSON parse it, but it's like almost less than 1 second to actually traverse the entire node. So so come to another point, which is Electron apps. Surprisingly, there are certain things that you have to take note doing cross-platform. Like I think there's no magic bullet, but it turns out that when I tried to run that on Windows, right, which I have not boot up for a long time, but I have a PC at home, and when I decide to try that, it actually works. It's kind of like pretty impressive. So the next thing, which so after I released the first version, there were requests that they want a tree map too, and one thing that is challenging is that D3 uses SVG, and that is SVG by itself it's not the problem, but when you're running thousands of objects in the DOM, and the browser will have a reflow, and that would make it really, really slow. So I end up having to implement it in Canvas and emulating the DOM, and so someone actually, some people mentioned after I did that, oh wow, it looks like this app called DaisyDis, and it turns out to be a 990 app. And I tried it. It's really cool. Like, I mean, it's like a company doing that. And but I mean, for anybody to, it's a compliment in a way that this is something that I did in just a few days could actually be pretty powerful. Okay, I'll skip all of this. So I think this is a really nice book called Generative Design. Okay. And I think these are more challenges. Like this is an open source project. So if anybody is interested, in my free time I will work on that. So one of the things that I learned that is visualization is useful. Like this is one of the latest edition of my app, and I think it would be more fun to actually give a live demo if we have any more time. Okay. All right, and let me scan. Let's say my Dropbox. And yeah, it's actually done already. It's really fast, and you can actually like go into the directory and say, oh, what is this framework? Okay, taking out. And I have like lots of PDF which I downloaded. And you can actually like go up this directory. And so one of the stuff with Electron is that the integration with shell, which is like when you right click and you see this pop-up window that's native, and here's like things like you can actually locate directly in the file system. You can right click on it and delete. At least I'm not going to delete now. And one of the realization when I was doing this is that I could actually apply this not only to this space but to memory. So this is my memory. And I can see that my app memory was taking up most of that. It's Google Chrome. And I actually tried with my colleagues. It's like everybody's memory usage is like being owned by Google Chrome. All right. And there's a tree map representation of that. Yeah. Okay, so that's for a very quick demo. So I think the point is that people say, oh, this has been done before, but I think by me doing this, I learned a lot of lessons that I could apply that to to the memory, which I don't see any apps out there doing that. And and I don't think there's any apps which you can download right now which have tree maps and the sunburst visualization. Alright, so it's nice to have you on there. So these are friends who actually sent me a screenshot. Oh wow, it's on the dashboard. Oh, the icon was designed by one of my colleagues. So I added a code like Mike Bostock, who's again one of the main guys behind D3.js. He says that visualization leverages the human visual system to augment human intellect. And I think that's actually a rephrase of, or based on the code by Engelbert. Sorry, I can't remember the name, but one of the forefathers of the internet. Okay, so there's a link to that if you're interested to take a look at it. So yeah, so I found that actually when I use this app, I could actually find a lot of stuff which is taking up my space. Like if you're using Google Chrome Canary, you will find that it downloads every version of every time it updates, and that takes up a lot of space. If you have Xcode, it downloads every new OS update, and over time it takes up like really a lot of space. So and that could actually be nicely spotted with visualization. So that's me. I'm Joshua, if nobody knows me. I work for a Czech company called ZopIM. Right. And I found out this. So this is a little bonus. I found that if you rename your GitHub repository, they will create links. So click on any of the links, it will go to my GitHub repository. And yeah, don't want me again about upload this space. Thank you.
question.
That's from me.
Okay.
I don't know if anybody else did, but real path. Did you take that into account? Because I remember I was traversing some stuff a while back, and it was taking forever. But it turned out that it was just going like it was following symlinks.
Yes.
Not symlinks and hard links. Only symlinks. Sorry, and that's what made it slow. Did you resolve your real path?
Yeah, that was basically a contribution to that, to the node DU. So basically there's the stat and there's lstat. So lstat will be able to, if it's a symbolic link, it is not a directory, it's a file. So you do not recurse, you do not traverse into that. So yeah, so
did you say that was my contribution to node DU?
Yeah.
Oh, okay.
So yes.
Great. Let's take a short break.
Yeah, take a break.
Yeah, just a short break.
I was thinking my name.